Very often, the question is asked, does science show that belief in God is credible? And we at the Maja Center answer this question wholeheartedly in the affirmative, yes. And one way in which science can contribute to the dialogue on the question of God's existence is that it can give evidence that seems to indicate with a high degree of probability that time, and consequently physical reality, had an absolute beginning. And one data source from which we can pull in contemporary science to establish this is the 2003 space-time geometry proof, constructed by three, you might say, heavyweights in the field of physics. Dr. Arvind Borda, who was the director of the Kavli Institute at the University of California, Santa Barbara, Dr. Alexander Vilenkin, who is the director of the Institute of Cosmology at Tufts University in Boston, and Dr. Alan Guth, who holds the chair of cosmology at MIT and is the father of inflationary theory. Now, there are two types of explanations for this proof, the mathematical and the logical. If anybody is interested in the math behind the proof, I would encourage our viewers to check out a video on our website, majacenter.com, of Dr. Alexander Vilenkin giving a lecture on the proof at Stephen Hawking's 70th birthday party in an auditorium filled with physicists. Now, we're not going to embark on that journey in this particular video cast. However, I am going to share with you a summary of the logical explanation. And for more details on the logical explanation, once again, I would encourage our viewers to check out our website, majacenter.com, and the various resources that Father Robert Spitzer and we at the Maja Center have produced on this topic. Now, Drs. Borda, Vilenkin, and Guth basically started with a principle established by the late Belgian priest, Father Georges Lemaitre, the father of the Big Bang Theory, and the American astronomer Edwin Hubble. And the principle states that the further away a galaxy is from us, the higher its recessional velocity will be. Now, recessional velocity basically refers to the velocity with which a galaxy is moving away from us at. Unfortunately, I don't have time to go into the details to unpack this principle and substantiate it, but suffice to say that it's based on what Father Lemaitre hypothesized and what Edwin Hubble empirically verified through his observations of red shifting, namely the expansive nature of space. You see, the idea behind the principle is that the more space there is between galaxies to grow, to stretch, or to expand, the greater the recessional velocity of the galaxy will be. And the recessional velocities of these galaxies will continue to increase as we move into the future, precisely because space will continue to expand, to stretch, and to grow. Now, Borda, Vilenkin, and Guth realized that as the recessional velocities of the galaxies increase, the relative velocities of projectiles moving toward the galaxies decrease. Now, relative velocity is the velocity of a projectile measured by the observer on the galaxy to which the projectile is moving. So, for example, if galaxy A is moving away from us at 40,000 kilometers per second, and a rocket ship is moving toward galaxy A at 100,000 kilometers per second, well, the velocity of the rocket ship as measured by the observer on galaxy A, the relative velocity, will be 60,000 kilometers per second, which is calculated by taking the initial velocity of the rocket ship as it passes by Earth, 100,000, minus the recessional velocity of galaxy A, 40,000, and thus you get 60,000. Now, let's say galaxy B is moving away from us at 80,000 kilometers per second. Well, the velocity of the rocket ship moving toward galaxy B, as measured by the observer on galaxy B, would be 20,000. Remember, 100,000, the initial velocity, minus the recessional velocity, in this case, 80,000. So, as we can see in this illustration, which, by the way, is an illustration that Dr. Vilenkin used in his 2006 book, Many Worlds in One, the relative velocity of the projectile, in this case the rocket ship, decreases as the recessional velocity of the galaxies increase. They're inversely proportionate. As one increases, the other decreases. Now, Borda, Vilenkin, and Guth would further realize that as we move into the future, the relative velocities of the projectiles would continue to decrease precisely because the recessional velocities of the galaxies are increasing. Remember, they're inversely proportionate. As the recessional velocity increases, the relative velocity decreases as we're moving into the future. From this, Borda-Vilenkin and Guth further concluded that if we trace the projectiles back into the past, we discover that the relative velocities of the projectiles would have been higher and higher the further and further back in time we go. Now, just to sort of summarize and take stock of where we're at, the further away a galaxy is, the higher its recessional velocity. And its recessional velocity will continue to increase as we move into the future due to the continued expansion of space. Next, as the recessional velocity of the galaxy increases, the relative velocity of the projectile moving toward that galaxy will decrease and will continue to decrease as we move into the future. And from this, we can reason that as we trace the projectile back into the past, its relative velocity would have been higher and higher the further and further back in time we go. Now we're in a position to see the implications of this reasoning for a beginning of time. If the relative velocities of projectiles would have been higher and higher the further and further back in time we go, well then, at some point a finite time ago, the relative velocities would have been virtually at the speed of light. But physicists tell us that physical energy cannot travel any faster than the speed of light. Therefore, we could not trace the relative velocities of the projectiles back any further into the past. We could not go 1 millisecond beyond that boundary when the relative velocities were virtually at the speed of light. So, as many physicists conclude, what this means for physicists is that past time has a boundary. And if a boundary, well then a beginning. And if time had a beginning, well then all of physical reality had a beginning, because physical reality is conditioned by time. Now, it's important to keep in mind that this Borda-Vilenkin-Guth proof or theorem is vastly applicable. It not only applies to our universe, but it also applies to the other alternative cosmological models such as the multiverse theory or the oscillating or bouncing universe theory. The only condition for the proof to work is that the model of physical reality under consideration have an average expansion rate greater than 0. Now, we know our universe has an average expansion rate greater than 0, and so the BVG theorem applies to our particular universe. But it also applies to the multiverse model and the oscillating universe model precisely because each of those models also have to have an average expansion rate greater than 0. And consequently, according to the BVG theorem, each of those models have to have a boundary to its past time, an absolute beginning of time, and thus consequently physical reality. So we see that the Borda-Vilenkin-Guth theorem is vastly applicable, and because it only has one condition, namely an average expansion rate greater than 0, well then it's very difficult to disprove, and it hasn't been disproven to date. Now you might be thinking to yourself, well, what's the big deal? Well, if time in physical reality had a beginning, that metaphysically necessitates a transcendent cause or a creator outside of time and physical reality that gave rise to the existence of time and physical reality, namely the cosmos. So in sum, the Borda-Vilenkin-Guth theorem gives us very probative evidence that seems to support the classic belief, the classic Judeo-Christian belief of those first 3 words in Genesis 1:1, in the beginning, from which we reason the need or the necessity in the existence of a transcendent creator, namely God, who creates the heavens and the earth.